Yes, many thanks, Alessio, for this great introduction of our workshop and the working group that is organizing it. And I have now the pleasure to introduce the opening talk, which will be held by Christian Franzke, who is one of our organizers for this workshop. And he has recently led a paper on perspectives on tipping points in integrated models of the natural and human Earth system, cascading effects and telecoupling, which fits very well to the context of this workshop. And the organizers of this workshop were also part of the author team of this paper. And so with this, we want to basically provide a setting for this workshop, and we hope for many fruitful discussions. So Christian is currently, he has recently moved to Korea to take a professorship at the University of Busan at the Center of Climate Physics in the Institute for Basic Science. And I welcome you to now give your presentation, and I welcome the audience to post any questions in the Q&A or chat, and we will have a discussion after Christian's opening presentation. So with that, welcome, Christian.
Okay, thank you very much for the introduction, and also welcome to all participants from my side. As Jana already mentioned, I'm going to talk about this paper we've written or published recently in Environmental Research Letters, which is also open access, so all of you should be able to download it very easily. But that was, that's part of our working group and also part of a little bit of the motivation for this workshop. And here is also the full list of all the other co-authors. And that also
can't hear Christian right now.
I don't hear you, Christian. Christian? We don't hear you anymore. Sorry. No? No.
Can you hear me now?
Yes, yes, perfect. Now you
okay.
I think we lost you right at the beginning, so I guess you need to say, after you introduced the co-authors, then we lost you.
Okay, don't know why. Okay, don't know when you lost me, but what I wanted to say is that's basically what we also call the opening talk. So that should be maybe some kind of a introduction and starting point to maybe then to have some discussions and maybe also shape the outcome of the workshop a little bit. So here we were interested in tipping points, especially how tipping points in the climate system might actually interact with tipping points in social systems or in society. So first I want to introduce tipping points more from the physical mathematical point of view, then a little bit from more the social sciences point of view, and then maybe the main part of the presentation and the paper is having this cascading hazards between the natural and the human Earth systems, how extreme events, that's what we focus on in the paper, in the physical system, could then also lead to extreme events and systemic risks in society. wrong direction. So what is a tipping point? So if you just look up a dictionary here, like the Merriam-Webster, that's just a critical point in a situation, process, or system beyond which a significant and often unstoppable effect or change takes place. That's, of course, a very nice, broad definition, which we can apply to the physical climate system, but also to social systems. So that we have some kind of threshold behavior. So that would be then the critical point. And after that, we might have or have to face consequences which might not be that easy to stop or to go back to the starting point. So if we look from a mathematical point of view and would assume that the system would be more or less linear. So if we would have here, so that would be, say, the trajectory of the climate system if we increase CO2 concentrations, if we assume that would correspond to, so if we increase this by a certain amount in a linear system, then we also have a proportional increase, say, in global mean temperature or in any kind of impacts. Now we know that the climate system is more nonlinear, so already a small increase in the forcing and CO2 concentrations could actually already have a relatively large impact change. So that's, but then the climate system could be, I mean, that already would be relatively bad in many situations. By just increasing CO2 emissions, we could have very, very severe outcomes, but the climate system might actually be much more mean in a way. So for different state, we actually would be to this them. And there we have quite a lot, just to maybe to focus on two. Maybe you've seen in the news in the media over the last few weeks. Also, there were some papers in Nature about Antarctic ice sheets and the trades glacier that's now kind of believed that it might actually collapse within a few years, and then that could actually lead to that a lot of ice might actually melt, go into the ocean, and then also raise global sea levels by very enormous amount. So that, of course, would then have very serious consequences for all low-lying countries and areas. Another potential tipping element, which I'm also going to talk a little bit later in my presentation, is basically the Lake Chad region. It's in the Sahel region. Here we have this threat that this might actually also go more to a much drier state in the future due to global warming. Also would be some kind of a tipping point or a tipping element in the global climate system. Okay, that was about the physical climate system tipping points. Now about social systems. And actually the term tipping point was actually introduced in social sciences by Schelling in 1971. And he developed a model to understand racial segregation in American cities. So that was the first attempt to use this term and to also model this. But actually later was found that this might actually not be supported by data, this explanation of racial segregation, but this term still kind of was very popular. Also in the climate setting was then popularized by Jim Henson and John Huber Wally-Bröker, because it kind of, also the media took it up. So that's also why it's actually also quite a nice term, especially if we also then talk to the public and the media. So how can we see, or are there really tipping points also in social systems? And there is some nice studies here about animal societies that they looked at spiders, and basically they did some lab experiments, basically increased the temperature, and then looked at the behavior of the spider colony, whether they become more aggressive or less aggressive. So the red lines is always we increase or they increase the temperatures, and the blue lines basically if we then decrease the temperature again. Here we have our temperature range, so from 27 to 33 degrees, and you can see here evidence, at least for certain colonies, of some threshold behavior up to 30 degrees. There's not much of a change, then it's an increase. But then if we then again decrease the temperature, we also again see this hysterics behavior. So basically we have to cool down to a much lower temperature to actually go back to this original state. So there's of course also lots of attempts of looking how this works in human society or groups. There's of course the idea, can we use social tipping points to trigger climate action? That was also one idea we discuss in the paper. There are also some studies where they basically ask people in a lab to basically communicate with each other, and basically then they ask about their opinions and whether they might actually change their opinions depending on the size of the majority also. And that they find that about 25%, or we would need some kind of a 25% proportion of a committed minority, so that might then need also to change in the opinion of the majority. So that's also, I think, very interesting, and that might also be useful to know when it comes to either to trigger climate action, or maybe to see how maybe extreme events might then affect certain societal responses. Okay, now talking about those two types of tipping points, now can we put them together or try to come up with a framework? There we looked at cascading extreme events or hazards or effects between the natural and the human Earth systems. One example here from my colleagues at my institute, if you look here at India, Himalayan, so of course due to global warming, we have high altitude warming, then we have increased snow glacier melting, increased river runoff. And at the same time, we also see that we have increase in intensity and frequency of extreme precipitation. And they basically, if they kind of occur together, so they actually can exacerbate extreme events, say extreme flooding events leading to loss of infrastructure and bad crop yields, but also, of course, health impacts, especially in this region. Flood-related diseases such as malaria, dengue fever, diarrhea are very common. And if we just look at the increase of the physical conditions, say that, as I already showed, we expect more flooding events, more precipitation extreme events, so that also under RCP 8.5 conditions, we actually would expect a much higher risk that those disease outbreaks occur. And that's, of course, then also will have an impact on health systems and societal responses. Another thing we discussed was teleconnected extreme events. There is a nice paper by Kaya Kornhuber, where they look at stationary waves, and they can basically lead to simultaneous heat waves, drought conditions over the bread baskets, so that we actually might have this simultaneous reduction in corn yields, and that also then could lead to food security issues and also would then amount to some kind of systemic risk. So that's of course also very interesting, something we in our working group very much interested in. Then what we discussed also in much more detail in our paper, the Lake Chad situation. So that's this basin here. Lake Chad Basin provides livelihood to more than 30 million people. And as you can see here from this map, so basically the Lake Chad region goes also into the states of Niger, Chad, and Nigeria and Cameroon. So already there is this complicated political situation that the water resources need to be managed by different governments. So there's also relatively complex water sharing arrangements as a mix of customary norms and state negotiated policy mechanisms. And it's probably very easy to imagine that in such a complicated setting, small triggers to the water levels actually can lead to big consequences. So if we look over the last 50 years, so there was relatively strong reduction in the water levels from about 22,000 square kilometers in the 1980s to about 1,300 square kilometers at its lowest point. Well, now, over the last few years, seems to have more stabilized, but also this region is very much affected by interannual fluctuations of the water levels. And that's, of course, in this region where you have not that many resources, can also trigger massive humanitarian responses, which is also here documented in the literature. And that's, of course, also some classic case of threshold crossings. And there are also many studies who kind of link this water management or this hydrological disaster, water management issues to rise of civil unrest. Some studies also link this to the rise of Boko Haram. You might have heard about the terrorist group. So that's say, one example where potentially those physical hazards, extreme events, tipping points can actually then really lead to severe societal changes and tipping points and then civil unrest. So in our paper, we try to summarize this in this schematic. Here's also maybe a nice summary of what I've talked so far and what the paper is about. So we have our physical tipping points elements depicted here in this map. Once we cross them, we of course have the impacts that we might have more extreme climate, weather extreme events that might then impact on ecosystem sustainability and of course water, food security, which then of course then also directly feed back into socioeconomic impacts, say that we have food price volatility, which then affects income, livelihood security, but of course also human health, disease spread. And that can then also lead to certain social responses. And depending on those social responses, we might actually delay our response or to take on climate action so that we actually might continue emitting greenhouse gas emissions and then might actually trigger other tipping elements. And then we would just close this loop here and go on and making it potentially worse. I mean, I should also mention here that schematic, so we cannot really display all possible responses, and also especially if it comes to migration, social unrest, there's also in the literature quite a lot of discussion how much climate change actually would contribute to this. And that's of course also many other political or economic situations contribute to this, but climate change is probably at least some factor in this. Okay, I come here now to my last slide. That's probably not really a proper summary slide, but maybe some more outlook what we would like to accomplish with this workshop, and maybe also if there would be more follow-up in afterwards. So that's what we see is what we would need to focus more is more on integration of feedback mechanisms between climatic and socioeconomic hazards, that we understand them better, and that would then also allow us to represent them in models. And that also would require an expansion of our currently existing models, which typically are single hazard or vulnerability models, to multi-hazards and multi-vulnerabilities, so that we have a much more complete picture and also could understand systemic risks much better. That, of course, is a core for also modeling of those systemic risks arising from those interactions in the complex systems. And that's, of course, for this, we need to develop new methods to quantify and understand the nature of those risks. That also requires a very good treatment of all the uncertainties, because here we deal with very complex systems, and especially how they interact. So we also have to consider the uncertainties, and that, of course, also requires very strong transdisciplinary collaborations. And that's, of course, also one of the major aims of this workshop, to provide a basis for this, and maybe to also hopefully start new of those interdisciplinary collaborations. And here is just if you're interested looking in our paper, then here is just a reference. Okay, thank you very much. I stop here, and maybe
yes, thank you very much, Christian.